Hi Year 10! As you're probably aware, the science department is isolating at the moment, so I've made this video to help you with your ionic bonding while we're off. So firstly, I'd like to recap what makes an ion. You guys should already be aware that an atom is neutral in charge. The reason for this is they have an equal number of protons and electrons, remembering that protons have our positive charge and electrons carry the negative charge. Therefore, by having equal number of these, we cancel each other out and having neutral charge overall. An ion forms when this atom loses or gains an electron. And here are some examples. Here we have a positive ion. This ion has become positively charged because one of its electrons has been lost. This means that there are more positive protons in the nucleus than negative electrons in the outer shells. This creates an overall positive charge. Here is a fluorine atom. This can become negatively charged if it gains an additional electron. Here you can see that negative charge from the electrons has outweighed the positive charge from the protons. So now we're going to look at how we can use that idea to consider how ionic bonds will form. Ionic bonding occurs between metals and non-metals, with the aim of filling the outer shell of each atom present. Looking at this example, I'm considering the reaction between lithium and fluorine to make lithium fluoride. So remembering our 2882 electron structure reminds me that lithium wants to lose one electron and fluorine wants to gain. The result will be that lithium forms a 1 plus charge and fluorine forms a 1 minus charge. This example is nice and straightforward because you only need one atom of lithium and one atom of fluorine to fill one another's outer shell, but this is not always the case. In this example, we're looking at the reaction between sodium and oxygen. Sodium has one electron in its outer shell and oxygen has 6. You can probably quite quickly identify that oxygen's outer shells cannot be filled with sodium's one electron. The solution is quite simple. Rather than reacting just one sodium atom to an oxygen atom, we will react two. What you must remember through this process is that within a chemical reaction, there are millions of atoms available. Here you can see the result. 2 sodium atoms with a 1 plus charge and 1 oxygen atom with a 2 minus charge. So now we're going to consider how we can represent these ionic reactions. I've drawn this for you below to show how we would show this. So what I've drawn is the electron structure for lithium and the electron structure for fluorine. Once it's become an ion, I'm going to show it with a bracket around it and the charge above. What you might notice is that I've no longer included the outer shell of lithium. Because its outer electron has moved over here with fluorine, in effect, this electron shell no longer exists, so we no longer need to represent it because it's not being occupied. Over here, you can see that fluorine has taken on an electron from the lithium and therefore has resulted in a 1 minus charge. My next diagram is for the sodium and oxygen. So, as you might remember or should remember, we had 2 sodiums reacting with 1 oxygen. So we'd need to show both sodiums reacting and the final oxygen. Here, each sodium gets a 1 plus charge because it's lost an electron to the oxygen. Again, we're not showing this outer shell any longer because we don't have an electron in it, and we can show a plus charge on each of the sodiums to indicate that they've lost an electron and a 2 minus charge on the oxygen to show that it's gained 2 electrons. So using our example of sodium oxide, we can see that opposite charges have formed on each ion. These opposing charges are the reason that a bond forms between them. We call these electrostatic attraction. These are strong forces that hold our ions together. The final step of representing ionic reactions is showing their ionic formula. The formula is there to show how many atoms of each type are present within the ionic compound. In our first example, the lithium fluoride, we know that there's a 1-to-1 ratio of the atoms. Therefore, it's simply LiF. However, with our second example of the sodium and the oxygen, we know that we require 2 sodium atoms to each oxygen atom. This means it is a 2-to-1 ratio, and this can be seen within the formula. Na2O. I've also given the balance equation below, as you may be asked to do this in your exam. Finally, here are some examples for you to try. I've included how many electrons there are in each and which group it's in to help you with its electron structure, as you may not have access to a periodic table. Please draw the outer electron structure, then the ions that will form, and finally give the formula. If you're looking for an additional challenge, try to do the balanced equation for each one. Pause the video now and answers will follow. Here are the answers to the questions I set. Each of the diagrams is included on there, and I've also got all of the ion charges. Please pause this if you'd like to take longer to jot down the answers. And finally, here are the formulas. These are not balanced. Here are the balanced equations. Chlorine and fluorine both have a small 2 after them because they are diatomic halogens. Okay guys, I hope you found that helpful. I've also included a PowerPoint slide with additional questions for your cover teacher to use. Take care and see you soon.